And I do like that we've had a diversity of topics here: feathered dinosaurs, fossil record, and now we've got Andrew. And so, Andrew, good to have you. I am interested to see what you're going to bring up in terms of arguments or topics. So, real brief intro, Andrew, and what would you like to discuss?
Yeah, can you hear me okay?
Yes.
Okay. Well, thanks for having me on, Donny. Nice to meet you, John and Joe. So I was gonna originally present one argument, but I'm curious to hear your thoughts on this instead, because I think this is more relevant to some of the issues that were discussed earlier. So a question I have for you initially is what issue do you have with Steno's law of superposition? Why do you think it's false?
Okay, I'll go in two directions and then Joe can take over. Where I have my house sits on rocks that are regarded as Ordovician now. Right now, it used to be Silurian, and before that, it was almost Precambrian. Now, since I was at university when much of this sort of change happened, I know exactly why they've made the change. Initially, the geology in Brisbane, they could not find any fossils in this submetamorphic to metamorphic rock. And then a student on the north side of Brisbane found what looked like a portion of a trilobite. So all of a sudden, it was upgraded from Precambrian and above. And then somebody found in a volcanic extrusion on the western side of Brisbane a portion of this rock blown out of the volcano with a datable so-called crinoid in it. And so the layering of the rock had nothing to do with the age it was put in. They were using an evolutionary accepted history of fossils and that, and then going back and changing the age of the rock. The rock hasn't changed one bit. It's still in exactly the same position. Now, that was my first
Can I respond to that first?
Yeah, that was my first introduction. Secondly, when I studied stratigraphy and ended up lecturing in coal geology, etc., one of the things I observed was that when you went into the field, finding rocks and fossils and finding coal had nothing to do with your view of the history of the area at all. You drilled holes, you dug holes, and you used your clues about what rocks you were in to tell you where the minerals might be. Now, I actually ran a course for technical education on geological mapping, and I told the fellow staff at the end of the year, what do you think would happen if I left out millions of years in evolution? Oh, you can't do that. I said, it's too late. I already have, and we have some of the best students we've ever had. And by the way, they're now out being coal mining geologists and mine managers and that, and it works. You have to deal with the real world, which doesn't come in the nice, neat layers that are in the textbook.
Okay, so I understand your point there about the fossils, and I appreciate your response there, but that doesn't really answer my question why you disagree with Steno's law of superposition specifically. You're talking about biostratigraphy there, but not superposition.
Historically, that led me back to what presuppositions am I using? If you've got to make up a new course, you have to deal with how did you get to where you are before you can teach students. So I ended up doing a real in-depth look at Steno and the thinking of the time. No doubt about it, a follower of Luther, a creationist, a biblical worldview, creation, Noah's flood, etc., but a medieval pseudo-Greek view of rocks and fossils. And if we can thank him for anything, it's belief that God made the world, God doesn't deceive us. So if we find a rock that looks like a shark's tooth, it's probably a shark's tooth, as distinct from medieval Catholicism or Catholic Greek thinking that it could have been a trick played by the gods to deceive us. So we can thank him for his big book on how to identify a fossil shark. From there, of course, he began to actually think out the bottom layer got there first, followed by the next layer, followed by the next layer, followed by the next layer. Now, it wasn't too long before I came across a comment from from an Englishman who actually said, if Steno is right, and this is John Ray, the guy who's just as famous but unknown for his work on the classification system that our friend in Europe gets more credit for, Linnaeus. And he said, basically, if Steno is right, the world is too old for the Bible to be true. So if you think that the rock at the bottom got there first, and then the rock above that got there next, then here's what follows. The creatures in the bottom had to live and die and get buried before the creatures in the next layer came along and lived and died and get buried.
Right.
Now, initially, Steno, of course, a creationist, that didn't even occur to him. He wasn't interested in dating creation, flood, present day. So primary, secondary, tertiary, quaternary rocks, the 4 layers which have a biblical basis. No problem with that part.
Well, if I may point something out here, initially you said that the ordering of the fossil record and the layers was based on an evolutionary worldview. Now you're saying Steno, who you're saying was in fact a creationist, that was not the case, that he found this out by his observations. Does that not contradict what you said earlier?
No, he actually, if I can correct you, he didn't find this out by his observations. That's why it's called Steno's presuppositions. He never went to see sediments being laid down. He assumed that the bottom layer got there first.
How else would they be laid down?
Well, that's why I suggest people go and have a look at our strata machine, because the water in the world is all flowing sideways. The sediment, therefore, is coming in sideways. Layers can only be laid down sideways if you are going to bring them in by water, and you have no other way apart from wind and volcanic action that will get them. So all the layers in the world
that's in that experiment are still laid down first. So superposition still applies.
No, this is not the case, because if you looked at our strata machine correctly, you'll see that the most dense layers actually end up on the top. And in fact, if you have a look at our European guy, the famous French guy who did that's right. What was his name again, Joe?
Guy Barteau.
Guy Barteau. Yes. He's got an incredible experiment that I watched when I went to the University of Colorado Geology section, a huge 50-foot flume tank, in which he was showing that the layers just don't do what we've been taught to believe. The layer at the bottom, we assume it got there first. The layer that's next,
can I share my screen here, Donny?
Say that again.
Give me 1 sec. I'm going to share my screen here because I know who you're talking about. I've looked into his experiments. Many others have looked into it. And while he did show that Steno's law of original horizontality isn't strictly true, that does not negate his law of superposition or the modern definition of the law of superposition. So can you see the diagram here, Donny?
Your voice is very breaking up for me, but that may just be my laptop. I don't know if it's the same for anybody else.
I think you're starting to break up a little bit, Andrew, now that you're sharing screen, but we do see the diagram.
Can you hear me okay?
Yes, you're coming in now.
Okay.
Did you want to make your point about the diagram, and then we'll take it off screen?
Yeah, so the law of superposition applies in a strictly vertical direction. So the bottommost layer is going to be older than the layer directly above it, adjacent to it in a vertical sequence. When you're comparing layer over here, so what you're showing in your experiments is a type of cross-bedding. The bottom set over here, more sediment is deposited on top of it. Even when you slow down the motion of the sediment being deposited there, that's still the case. In a strictly vertical direction, superposition still applies, and that's how it's applied in field work. So no, your experiments do not disprove Steno's law of superposition.
Okay, take you one step further. The thing that inspired my experiments was Professor Allard Wilson, who was our professor, a very famous man to deal with continental drift, etc., walked into our teaching room one time in third year geology and said, students, I hate to tell you this, but the rocks in the Grand Canyon get old sideways. In other words, they've been deposited from left to right. So the fossils up here are actually older than the fossils in the same layer further down the stream front.
And sure, so if these layers basis for that.
Well, the fact that I've been to the Grand Canyon many times since then, and he's actually right. There is a current direction. You can even see it coming with the rocks that came in from Tennessee to end up in the sandstone at the top of the Grand Canyon. So the rocks have moved sideways. The minute you establish the rocks moving sideways as your principle, then all of a sudden it may be at the bottom up here, but it's way older in theoretical terms than the one in the same layer 100 kilometers further down the track. And likewise, if this got there before this one here, then the one at the bottom there.
I understand your point, but let me stop you there, because not all the layers you see in the Grand Canyon have the type of cross-bedding that you see in your flume experiments. So concluding that they were all deposited horizontally in a lateral direction does not follow. In fact, we have evidence they were deposited horizontally in a vertical direction, so one on top of the other. Why don't we see cross-bedding in all these strata if they were deposited laterally?
Professor Wilson and I would have to disagree with you there. And I've climbed in and out of the Grand Canyon many times. And if you have rock layers being deposited, yes, I appreciate you'll find some cross-bedding there. But in reality, if you have rocks coming in one on top of the other from multiple events, then you need to establish where your eroded beds are and all those sort of things.
So we're not talking about unconformities here. We're talking about the cross beds within the layers. Why don't all the layers have cross bedding if they were deposited horizontally?
I would suspect that if we could afford, like Guy Barteau, to have a huge strata machine, we'd show that cross bedding is not necessarily an example of it at all. It's just one example.
So then you don't have evidence that these layers were deposited horizontally at the moment.
In the Grand Canyon, I agree with Professor Wilson. They definitely do show being. If you're looking and saying that cross-bedding has to be an example of the way of bringing it horizontal, I don't necessarily agree with that. It depends on the speed of your water.
Well, yes, but the flume experiments that you used show cross-bedding. So if you want to use your flume experiments as evidence that all these layers were deposited horizontally, you need to show the cross-bedding. The fact that we don't observe it means they weren't.
That would be one case only. And if you want to donate money to send us, give us a huge strata machine, we'll happily take it. Eh, Donny?
I think also you'll see that cross-bedding is not the only example of a geological feature that you see within the flume experiments. The initial flume experiments were based off of not only Guy Barteau's, but I forget the other guy from Venice, who worked on delta, particularly the Venice delta, and you don't have cross-bedding there, but you do have sediments that are moving sideways as they are forming layers, what should effectively have the appearance of one on top of the other, but they are moving sideways. So just as John said, you can trace flow, which cross-bedding is not the only example that you can see in flow. You can trace the flow from Tennessee all the way down to the Grand Canyon, and it's not necessarily just cross-bedding.
So right, but we can show that all the layers in the Grand Canyon are not all from a deltaic environment. We can tell that from other sedimentary features.
Oh, we're not just purely saying this is a delta, therefore that's a delta, or this is cross-bedding, therefore that's cross-bedding. What you're showing is a principle about the way that sediment behaves when it's in water. Because the old, primary school example of stick stones, sand, and mud in a glass jar and shake it up and down, and then allow the water to settle and then watch the sediment sink down, effectively giving your example of Steno's principle of superposition, which is in every kindergarten, learn about rocks and fossils book. It would be a wonderful principle if the world was a glass of water, but it's not.
No,
because
that would be the law of original horizontality, not the law of superposition.
Before you even get to water being suspended with sediment to settle one on top of the other, you still have to get the sediment in the water in the first place. So take it a scale back and you look at sandstone. For every cubic meter of sandstone, you require approximately 3 cubic meters of some form of granitic rock to be eroded away in the first place, which again comes from flowing water equaling erosion. So we're dealing with a much, much bigger picture than just purely cross-bedding as an example.
Sure, I agree to that point, but the fact is that you're talking about the law of original horizontality, which even before Guy Barteau's results, geologists already knew that. So it's possible for layers to be laid down in a non-vertical direction, so horizontally, and the law of superposition will still apply because, again, sediments, there has to be sediments there to be deposited there before sediments on top of it get like that. One does not exclude the other, is what I'm saying.
And before you respond, Joe, that is time. I appreciate it, Andrew.
Okay.
So John, Joe, let's give you the final word, and then we'll move to the next person. Go ahead.
Over to you, John.
Whilst you may have a case in point for certain points of deposition where one equaled the other, in reality, I repeat, I agree with Professor Wilson, having walked the Grand Canyon this way, that way, and everything else, and having looked at where the sediments come from, such as the ones in Tennessee, you will find that they are massive beds, and the principle of superposition, whilst it's used to say the bottom layer got there first and so on up, when you look at it, the bottom layer, the first rocks are the ones in the east, the last rocks are the ones in the west, even though they are stratigraphically identical.